I should add an addendum to exercise 1413 at part E. With respect to what I had done, I was getting a little bit misleading. In the first, when we first start this up, we're going to have a little bit of a transient, and we are going to go, let's say if we started at 0, we're going to go up to about 2.5 volts, and then we're going to start to kick in, and we're going to go down. So this slope is 5 volts per microsecond, or that's going to now be 2.5 volts per half of a microsecond, and that's what we have in each of these intervals between the positive and negative pulses. So now we want to go from this 2.5 value in terms of voltage right here. In 1 microsecond, we would try to get down 5 volts from that, which would be at this minus 2.5, and that would be over here in terms of its value. But we're not going to get there. We're going to turn around at this particular point. So now we've maybe gone just a little bit below 0. Then we'll start back in the positive direction again, and we won't get quite up to 2.5. After a transient, what we're going to see is that we're now changing every half of a microsecond. We are now changing 2.5 volts every 1/2 microsecond, which means that eventually we are going to settle down and have happening. Here is what the ideal was trying to do. That's not a very accurate sketch, but we started up going and we went to 2.5, but now what we're going to end up with in the steady state is we will now be equally centered around a 0 level voltage, but now we are only going to be changing 2.5 volts per every half of a microsecond, which means if we're now equally distant positively and negatively, and we have a 2.5 volt peak to peak. So this peak is now going to be 1.25 volts. This is going to be minus 1.25 volts because we're now transitioning 2.5 volts every half of a microsecond, and we will now be oscillating at 1.25 to minus 1.25 in our triangular waveform in part E of exercise 14.13.